In today's class, we're going to learn about data centers. Introduction. Why data centers? So let's take a step back and look at the origins of data centers. Back in 1950 and 1960s, computing was dominated by mainframes. We're using COBOL. These were essentially the first centralized computing facilities. Only the governments and militaries and very large corporations could afford them. As computers became smaller and cheaper in 1970s and 1980s, companies started buying their own servers and sticking them in the closets or small server rooms, but soon they realized this wasn't sustainable. Cooling was a nightmare, power consumption was very high, and every company was reinventing the wheel on how they are storing these servers. So, the idea of the modern data center emerged. Instead of every company building its own server room, why not centralize computing into a larger, professional managed facility? By 1990s, with the rise of the internet, dedicated data centers became essential. Companies like Equinix and Digital Reality started building massive facilities where businesses could run space for servers. This was the early version of outsourcing IT infrastructure. And coming back to our slides. When we talk about cloud, it's easy to forget that it all lives somewhere physical, and that place is the data center. The idea is simple. Instead of scattering servers everywhere, you group them together. That way, you can share power, cooling, and the staff that manages these servers. Imagine one big library versus hundreds of tiny book collections spread across towns. Centralizing makes it easier to manage. Modern data centers house everything: servers, databases, networking, telecom gear, etc. etc. And cloud providers take this idea to the extreme. Their data centers are more like the entire cities of IT infrastructure. In these facilities, we have both physical and virtual resources. Physical means the actual hardware racks, CPUs, operating systems, etc. But managing thousands of physical servers one by one would be impossible. That's where virtualization comes in. It abstracts the hardware into flexible virtual machines, like slicing a pizza into pieces you can share. A single server can host many virtual servers, each running different applications. Virtualization platforms let admins allocate, monitor, and scale resources without touching the physical machine. Standardization and modularity. Another secret to data center success is standardization. Instead of exotic custom built servers, most data centers use standardized commodity hardware. Think like Lego blocks. They are just like servers, they are easy to stack and replace and scale. Modularity means you can expand by adding identical blocks, not by reinventing the wheel every time. It also means when one server dies, you just swap it out without disrupting the whole system. Economics of scale also kicks in when you buy a lot of something. When you buy thousands of servers at the same time, everything becomes cheaper, easier to maintain, and easier to replace. Here's a futuristic concept: autonomic computing. It means systems that can manage themselves. Think of it like a human body that regulates the temperature, the heartbeat, blinking of eyes. In the cloud, autonomic features include self configuration, which means new resources spin up automatically, self optimization, tuning themselves to better performance, self healing, detecting failures and fixing them, and self protecting, defending against all of the attacks. For example, if the server fails, the system automatically shifts the workload elsewhere, maybe a different rack, maybe a different location, and it does it before the users even notices. This automation is the key to making cloud scale reliably. Remote operations and management. In the old days, IT staff would physically walk into server rooms, swap disks, push buttons, and in modern data centers, that's rare. Most tasks are handled remotely through secure management consoles. In fact, many technicians aren't even allowed inside the server rooms except for the hardware work. This reduces human error, keeps the environment controlled, and allows one person to manage hundreds or even thousands of servers from a single dashboard. High availability. It means the data center is designed to never go down. Outages are expensive. We can't imagine the losses Netflix or Amazon would face if they go offline for 10 minutes. So, data centers build redundancy everywhere. Multiple power supplies, duplicate network links, backup cooling. They also use load balancing and clustering, so if one server dies, another instantly takes over. The goal is to make failure invisible to the user. Security aware design. Security is baked into every layer. Physically, only authorized personnel can enter, often with biometrics. Logically, data is encrypted, access controlled, and constantly monitored. Discovery strategies are in place so even if a breach or a disaster occurs, data is not lost. Data centers hold critical business information for thousands of clients, so security is not an option. It's a core design principle. Outsourcing evolution. Before cloud, companies outsourced data centers to third parties. This reduced costs but came with rigid contracts. You had to commit for years and scaling was painful. Cloud changed that by making resources elastic. Elastic is something that you can scale up and down, and it's done instantly. And you can only pay for what you use. That's what made cloud data centers revolutionary. And this class is very short because I wanted to go over the first assignment for you guys. The first assignment has two different topics. The first one is define cloud in your own words. List two services that you use every day, like Gmail, Netflix, and how they are connected to the cloud. Explain the differences between on premise, IT, private cloud, and public cloud. That's part A. Part B, you are doing a cloud scavenger hunt where we have a lot of services. So you have to choose one major provider, may it be AWS, GCP, or Azure, and identify and describe one infrastructure as a service, one platform as a service, and one software as a service. I keep the descriptions plain and beginner friendly language, and you have to have 500 words of description for each part A and part B. Uh, let's conduct a quiz on next Tuesday around the same time for the class. And all of the information for the quiz and assignment would be published on Canvas announcements. If you have any questions, then feel free to reach out. Finally, I will send over the meeting link for tomorrow's live session. If you're not able to make it for some reason, then I'll still record it and then post it afterwards, so you don't have to worry. But yeah, that's all for today's class. See you tomorrow.